or you know what I mean, Unit 2, Part 1. So I think you should do fine with this material. We're definitely going to get through this set of slides, and there'll be an assignment at the end. And then actually on Wednesday, there's a good chance we'll get through that slides, and there'll be an assignment also. But I like this. You know, we've been talking in here how you classify matter as either a pure substance or a mixture. And if it is a pure substance, then that means it's either a compound or pure element. Okay? So we want to focus on compounds. And remember that compounds actually can be broken down. And I think I've got a few videos that we've already seen before, but I think we'll just go ahead and show them right quick again. A compound has 2 or more elements that are chemically combined, and we use a chemical formula to represent that compound. This is showing you magnesium oxide. It starts out, I believe it's a powder, and it ends up as the silvery, I don't know what, it's a silver mercury 2 oxide. Yeah, mercury 2 oxide, where we have the liquid mercury here and the oxygen leaves. So it looks like this was the little animation we looked at. Chemical formulas to represent compounds. One of the things I like about chemistry is that a lot of times it's very succinct. It's not very wordy. So one of the things that, in case you didn't already know it, I want to talk just briefly about, for instance, this guy right here. This is ammonium sulfide, and this little 2 means that we have 2 of those groups. So ammonium sulfide would look like this. It has a central sulfide ion, and it has 2 ammonium groups kind of spreading out like that. So just kind of keep that in mind. I want to touch again, and we'll be even hitting it again even more, but remember that I said there's 2 types of compounds. Like if you were doing the logic tree, matter can either be a mixture or pure substance. If it's a pure substance, it's either a compound or an element. If it's a compound, actually there are 2 options here. The type of compound can be a molecular compound, synonymous with a covalent compound, or ionic compound. And we're actually going to be using these terms today. If somebody talks about a molecule, then they must be talking about a molecular compound. If they're talking about a repeating unit in terms of a formula unit, that must mean that they're talking about an ionic compound. It's common that you'll run into somebody who says, for instance, table salt, NaCl, is an ionic compound. They might say, I have a molecule of NaCl. And they're like, no, you have a formula unit of NaCl. So these are all molecular compounds. The thing about a molecular compound is it's nice and it's very family oriented. So for this water molecule down here, we know that this particular hydrogen, this particular oxygen, those 2 particular hydrogens and this particular oxygen, those 3 atoms go together for that particular molecule. Okay, ammonium, we have a nitrogen and 3 hydrogens. Okay, methane, carbon, and 4 hydrogens. Incidentally, these little dots up here, those are actually a pair of what we call lone pair electrons. And the thing about lone pair electrons, you think about electrons, they're just kind of little tiny, don't have any mass to them, but what they do have is volume to them. So actually those lone pair electrons around that nitrogen atom will kind of scoot the hydrogens down. Notice here with regard to the water molecule, we actually have 4 or 2 pairs of lone pair electrons that create space and kind of drive those legs of the water molecule together. So in chemistry, it's handy to sometimes talk about methane this way, sometimes look at it structurally. This would be a little bit more look, and this is even kind of a different look. Those are all CH4s. These are all benzenes. The formula for benzene is C6H6. And it's kind of cool because this actually, a few things about benzene. You kind of see that it's cyclical. It's a cyclical compound. The other thing is maybe you notice we have a single, double, single, double, single, double between those 6 carbons that make the carbon ring. And that's kind of neat. We'll be talking more about that, those chemical bonds, singles versus doubles. Vinegar. So the formula for vinegar is CH2O, and here's what that looks like. It has the carbons oftentimes joined together to make kind of, in this case, a very short carbon chain. At the end of the carbon chain, we have 3 hydrogens. We have, and this is a carboxyl group, the hydroxyl and the carbon double bond oxygen. Again, acetic acid, that's vinegar. We just looked at that, right? Oh, sorry. C2. Oh, sorry, empirical formula. My bad. I was like, oh, there's vinegar. Okay, and then here's vinegar. Vinegar and acetic acid are the same thing. And then here we have methylformate. You can see an oxygen inserted in the carbon chain. These, all that I've shown you, and I'm going to show you how I know this, but these are actually all molecular compounds. If there's a metal in your formula somewhere, then it's an ionic compound. No metals. Remember, we know the metal if we find the JAGs, and we have everything to the left of the JAG are metals, and to the right are nonmetals. So carbon, hydrogen, oxygen are all nonmetals. Carbon, oxygen is clearly a nonmetal. Hydrogen, we consider it a nonmetal for 95% of the time. So looking just again a little more at what we mean by molecular versus ionic compounds. Molecular compounds, I told you that, for instance, this cute little water molecule, we know that that oxygen goes with those 2 hydrogens. But what are these? Low pair electrons. Yep. Exactly. So ionic compounds, we're going to take a look at, I think we saw these videos before, but ionic compounds will have a metal. Again, you can kind of see the rainbow going around, or the colored strip, so that's an open stacks. Open stacks carbon slide. Again, sodium chloride. So the thing about sodium chloride is like what I was talking about a minute ago. You can pick any, if it's in its solid crystalline lattice form, you can pick any ion and go either any way and you'll get 6. You run into 6. So you just don't know. You know, it's a community. It's more like a network. So chloride. Okay. So here's where I said look for the metal in the formula, and it's an ionic compound. Okay. If you have a compound that has all nonmetals, then it must be a molecular compound. And what did I just say about hydrogen? Metal or nonmetal? Yeah, I think she said, yeah, hydrogen, consider it a nonmetal. And about 95% of the time. On those, sometimes students, you haven't asked yet, maybe you've thought it, but I've asked why on my periodic tables, why do I have hydrogen twice? And that's kind of why I have hydrogen twice. Because sometimes it behaves kind of like these guys over here, and sometimes it kind of behaves like these guys over here. So yep, on my periodic table you're going to see it twice. So the crux of what today's little thing is all about is to come up with how much a molecule weighs or how much a formula unit weighs. So hopefully with the discussion I just did, you know that all we're talking about is a repeating unit of a molecular compound or a repeating unit of an ionic compound. Then the other thing is what we've talked about recently is in order to know how much an atom of each type of element weighs, what do you do? How do you know how much an oxygen atom weighs? How much does an oxygen atom weigh? 16.01. Yep, looked at the periodic table. Yep. Yep. So, you know, we'll try not to make it harder than it is, this sort of problem. Now, I use weight and mass interchangeably, even though they aren't really interchangeable, but I use it interchangeably. So if I say molecular weight, weight of a molecule, or molecular mass, mass of a molecule. All right, and I'm going to be using the average atomic weights from the periodic table. So I have some examples coming up. This is aspirin is C9H8O4, and you can kind of see, it's like a benzene ring here, doesn't it? With another carbon, and then the red are oxygens and the white are hydrogens. So you can kind of see how it's arranged. But all we got to do to see how much it weighs, this would be a molecular weight since it's a molecular compound, since carbon, hydrogen, and oxygen are all nonmetals. So you take 9 times the decimal number for carbon, 9 times 12.01. And then you need 8 hydrogens, so 8 times the decimal number for hydrogen, which is 1.008. And then last but not least, we have 4 oxygens, 4 times the decimal number for oxygen, 16.00. Oh, I guess it's 12.01, 16.00. And then you add them all up. Now, these numbers right here in the quantities, these are exact, but of course we've talked about these numbers for the average atomic weights are rounded, okay? So as it turns out, it's not that complicated, but these, let's see. There's no uncertainty brought by these numbers, so this is kind of like just adding them together. Like for instance, this with hydrogen, it's like adding 1.008 plus itself 8 times. So if we're adding, we can go with 3 decimals. Anyway, when we come to add, since we're adding, how do we need to round? Decimal places, 2 decimal places. So 180.15 would be the molecular mass. All right. Oh, and don't forget, I don't have it up here, but don't forget what units are how much it weighs? AMUs, yep. Very good. So don't let that catch you. On your test on Thursday, the heading will say, be sure you show all your work, and the heading will also say, be sure you include units and round appropriately. So, all right, let's do another one. Well, let's look at the other type of compound. The other type of compound is an ionic compound. You're going to have a metal somewhere in the formula, but we're going to do it the same way, and we're going to calculate it the same way, but now it's going to be a formula weight. All right, so here we have sodium chloride. There's 1 sodium, 1 chlorine, okay? So we take 1 times the decimal number of sodium plus 1 times the decimal number of chlorine, and we get, and then we add it together, round to 2 decimals. So 58.44 AMUs. See, seems like it just should say AMUs. That seems like a naked number to me. But anyway. Cool. So I've got one of each now. Instead of kind of showing that like tabulature, this is how I would usually do mine. So hydrazine, again, must be a molecular compound because nitrogen, find it on the periodic table. If you haven't used the periodic table a whole lot, you might not right off the bat know that nitrogen is a nonmetal. Find it in the JAG. Hydrogen nonmetal, so we have a molecular compound. So how much does this thing weigh? Well, I'm going to have to account for the nitrogen. And the decimal number for nitrogen is 14.01. So I would take 2 times 14.01 AMUs, that's nitrogen, plus 4 times the decimal number for our hydrogen, which you're going to probably memorize by the end of the semester, is 1.008 AMUs. Rounded to 2 decimals is 32.05 AMUs. So that's probably kind of how I write it. I write it without this pink stuff down here. All right. So that's a molecular compound. Let's do an ionic compound. CaNO3 quantity 2, calcium nitrate. Where is the metal in this? Which element is a metal? Calcium is metal, yep. How many oxygen atoms are there in one formula unit? 6. I heard 6. Yep. All right, so here we go. Got to account for the calcium, the nitrogen, and the oxygen. And it looks like this. Just string them up. 1 times the decimal number for calcium, which is 40.08, plus 2 times the decimal number for nitrogen, which is 14.01, plus 6 times the decimal number for oxygen, which is 16.00. And then round to 2 decimals. This would be one where students might 164.1. Oops. You know, you have to make sure you write it correctly. You need that trailing 0 after the decimal. Homework's due. I know. I think we're just gonna go ahead and stop there because I won't get too far ahead.
Yeah, that's wonderful.
But Wednesday, I think we are gonna do the mole mass, which is even a little more interesting than this. But it's pretty straightforward. So, but don't forget to be doing those